Good morning, and thank you for joining Modern for the second session of the Civil 3D and iDAS. We still have some attendees that is logging in, but we will start in a few seconds. Just hold on for us. Thank you guys for joining. I am Salome Fourie, and I'm one of the Civil Infrastructure Account Managers. I would like to introduce our Batman, our applications engineer that will be presenting today, Jacques Pieterse. If you have any questions, please add it to the Q&A box at the bottom. Jacques will answer all your questions after the presentation. If you've got any other queries or anything, just let us know in the chat box, and then we will answer you as soon as possible. Enjoy, and I'm going to give this over to Jacques.
Good morning, ladies and gentlemen, and welcome back to part 2 of our Civil War series. So for those who already joined for the previous webinar, we have got this nice little Civil War reenactment going on. How to go define your civil projects using Devotech iDAS as well as Civil 3D. So for this session, we're actually going to focus specifically on gravity pipe networks as well as pressure type networks. So we're going to look at the old-fashioned way versus the new way. So just before we actually start off with the main elements, I'm just going to quickly run a poll again, just to get a feel yet again for the crowd and what they are currently using. So we're going to send up 2 polls. They are going to be only available for 30 seconds. So I want you guys as quickly as possibly to answer them. So we can quickly run the first poll, Salome. So the first one would be, would you be interested in Civil 3D and Devotech iDAS workshops? If it's a 2 to 3 hour sessions once a week, we would love to hear your comments on that. Then the second one, but we would like to run, just to give a quick statistics. Oh wow, the results is like 97%. Okay, the audience has spoken, and we will definitely look into that. Thank you so much. So the second poll we want to quickly just run is basically, I just want to get a feel, does any of the audience actually use SSA, and if they know what it actually is at the end of the day. So I would love to have your feedback on that, because we're going to discuss a bit of SSA in this entire webinar, and I'm going to still go into depth in what it actually is, but I just want to get a feel for what type of audience already using this as their analysis type. So we can just give a few more seconds, and then we can just look at the results. So the drum roll is, great. So the statistic says about 27% actually uses SSA. That's kind of interesting. As well as no, 73%. So that's good. We've got a different types of views on the system. So this will be beneficial for both of you at the end of the day, and you will also relate to some of the elements that we're going to discuss. So just before we start off, I mentioned Devotech iDAS. So just to clarify for the clients that still does not know what Devotech iDAS is. So basically, who are they and how do they assist with this war? Now, Devotech iDAS are a South African software development company. They actually provide automated design functionality to the engineers industry within the Autodesk Civil 3D interface. So basically, it's an add-on to Civil 3D with its separate licenses. As well as Devotech iDAS transforms your Autodesk Civil 3D to complete BIM design application, which enables you to perform all design aspects without importing or exporting data to other designs or analysis modules or software. So basically, it's all built in one. And that's actually the most accurate and the most convenient type of scenario in my own personal perspective. Then for Devotech iDAS, it actually builds on top of the Autodesk Civil 3D database and allows you to share design with other designers who do not have Devotech iDAS products. For example, if you've got for a civil designer, model maker, and such and such and such. as well as Devotech iDAS has various licensing options, as well as standalone and network licenses. So just to give you guys a nice little idea how it looks like in the actual Civil 3D, it has this little additional iDAS icon with its own tools. So for today's Civil War Part reenactment, engineering pipe designs, today we're going to do something completely a little bit different. Let me just close that. Sorry about that. Is basically we're going to look into the main overviews of battle strategies. So we've got two teams, blue team and the red team. Now, blue team consists of the following. We've got Civil 3D and Storm Sewer Analysis, which actually stands for SSA. As well as the topics that we're going to discuss is the gravity pipe network stormwater overview and the pressure pipe network, which is the bulk water overview. The same is going to be accounted for the red team, which is the Civil 3D and Devotech iDAS. And they also have their own gravity pipe network stormwater overview, as well as the pressure pipe network overview for bulk water specifically. Then for the final war reports and statistics, we'll get to that point after we've reviewed all of these types of strategies. So first up, the blue team. So Civil 3D and Storm Sewer Analysis, what do they actually have entailed? So for the guys that still doesn't know what storm and sewer analysis actually is, let me just elaborate a little bit. So normally if you install Civil 3D on its own, it actually comes with storm sewer analysis. So it's basically an additional package which is already included into the Civil 3D. Now, what in the storm sewer analysis actually happens is basically you export all of your pipes into the SSA and do your actual analysis. So how does that entire workflow actually look like? So for the gravity pipe networks, we need to firstly manually model the pipe networks using Civil 3D tools. Now, the one key defect about this that the pipe networks, the catalogs that actually comes with it is not South African standard based, which is very problematic because you need to make sure that these things are as accurate as possible to the real life scenario. Then what I need to do is before I can send all of this data to SSA, there needs a piping migration. Now, this is performed by hand inside of Civil 3D settings to tap for both pipes and for structures. So you literally need to go down and literally assign each element to a specific migration. For example, a pipe is a pipe, inlet is an inlet, a manhole is a manhole, junction is a junction. It's a very tedious process. But that's how we used to do it in the old days. But basically, the next step then after is the catchments and the pipe networks must be submitted separately into SSA in a manual manner. When I speak about manual manner, it's basically you send the pipe networks as an STM file, as well as the catchment actually comes in as a LAN XML. So you need to export both of those elements to SSA. There's not a one click and it's actually there. You need to export them separately. Then for the project and analysis options, they need to be set up inside of this SSA itself. So the system can be analyzed and the pipe sizes can be changed inside of SSA. But here comes the kicker. If I'm exporting data back to Civil 3D, it must be done manually. This just adds the pipe sizes to Civil 3D. So basically, it will update the size of your pipe if, and I say with a big if you set up the piping migration the correct way, because as you send it in, there's a migration. If you send it back, it also has a migration. So normally 99% of the time, it's sometimes much easier just to swap out the parts inside of Civil 3D than rather trying to export and import these elements, import it back into Civil 3D. Then the most critical thing of the entire designs, which I personally do not enjoy, is the fact it lacks the design data in our long section. So you need to actually go and manually create these elements using normal AutoCAD text, ladies and gentlemen. And that's what is the most, I can't explain it how frustrating it is. Basically, because that's what we need to show in our long section for government and our agencies and so on and so forth. I need to know what's the velocity. I need to know what's the discharge so I can put it into my long section. Then here comes another brainer. If the model has been changed inside of Civil 3D, this entire workflow needs to be modified from scratch. So you need to import again, redo your analysis, change the pipe, go back to Civil 3D, bring them in. Then you need to go and actually add the text. It's crazy. So just to illustrate that a bit better, I'm just going to explain a quick video. So if you actually go and export now yet again the long tedious process of the pipe networks as well as the catchment. So the first things first, it will bring in these catchment areas, is this shaded area, as well as it defines them for each catchment and the pipe networks. Now, the following step is after you've imported all of your elements, you need to go to your project options where you can specify what type of analysis you're doing. So I'm not going to go into technical depth around this, but basically you specify what time of concentration you want, as well as you can actually predefine the flow length, which is actually your longest path on a certain area of an catchment. So then you can specify if those elements are adequate and to do that. So after you set up the project manager and what type of analysis you're doing, you need to go to each individual element in the sub-catchment areas. So if you go select, for example, this first sub-catchment area, you can go define yet again its flow length. Now, sometimes you can do this manually because you need to link it to which inlet, as well as you can specify the roughness coefficients, basically for that specific material or specific catchment, which contains certain criteria. You can actually go define the roughness coefficients for them. Now, it actually does calculate the weighted coefficients, and you need to also specify the outlet node. So which KI is this going to, or which inlet is it going to go flow to? So it depends on whatever type of scenario you're using. Now, the tedious process about this, you need to do this for every single one of them. And remember, if there is updates that's required, it basically will make you do all of the steps over and over and over again. So basically, you need to go define every set area again with the roughness coefficient. Now, sometimes if you did copy it over, it doesn't read it. So you need to actually go still manually change these elements inside. So you need to link it to the actual inlet. Yet again, just to show one more time, if you go to the actual paste, you can see it sometimes does not pick it up. So I need to manually go and change these elements and make sure the inlet selection is correct. You can do a little bit of adjustments afterwards when you've already set this up. But the most critical part is you need to link it to your system. Otherwise, it's not going to calculate any flow into your catchment areas. Then finally, I'm going to just do the last few, jump a bit. So after you've now actually added all of your catchment areas and linked them to your junctions, you need to go specify your ID of curve for the specific design criteria. Now you can go do that in your applications options, and then you can start specifying, for example, what time of analysis you want to run, as well as the storm sewer, what's your return period for what type of design you're doing. Then you can actually perform the analysis after that. So basically it will work out all of that discharge onto your inlets, and inside of your inlets, you can actually go and see the results inside of your long sections. Now, there is a profile plot function inside of SSA that actually allows you to go and view all of this data, and you can see it gives you all of that information. You can actually go play and output an animation, which we will do a bit later. But basically, it actually showcases all of your design details inside of that profile view. So basically, most of that hard work has already been done. So the next step is basically, let's try and flood this entire scenario. Let's say 1 in 50 year rainfall intensity, and I rerun the analysis. So what I want to do is I want to flood this entire system, and as you can see, it actually highlights. So it shows case that the pipes are probably flooded in my case, and I can actually go and just make sure that these pipes are according to standard. Now in my case, if I do play this along, you can see it actually dictates where I've got full manuals, as well as when my pipe is fully underwater. So you can actually go and look and animate this even more, and it actually does provide all of the nice details. That's the beauty actually about this. They actually do have all of the details, and then you can actually go redefine your pipe sizes. Now the pipe sizes, you literally need to select per pipe to change the pipe sizes, diameters, and then you can rerun the analysis. So as soon as you do that, you can see the modification has been changed, and I need to go and make sure the last two is also designed. So you do that manually, one pipe at a time, which is a bit tedious on my ends, because you can think if you've got a big stormwater network, how long this is going to take. So as soon as I've done all of that hard work, I can just confirm that all of these pipes are properly designed and there's no flooding or fully discharged. Then if I want to export this, you can actually either export it as an STM file, or if you want to export the other elements, you can also put it as a LAN XML. So that's basically a very long process of how to design these things. And like I said, you can actually animate it back into exactly what's happening inside of your network. Now, I personally, I love this type of network, but the only problem is I need to export these things back to Civil 3D. And that's where the problem comes in. So as soon as I sometimes go into Civil 3D and I export the pipe sizes back to it, I still don't get my actual data inside of my long section. So it kind of beats the point of basically going that route. Then finally, we've got for the pressure pipe networks for the bulk water overview. So I'm going to quickly discuss about that. So yet again, we need to manually build the pipe networks inside of Civil 3D tools. The pressure network does not contain a catalog for the structures and pipes, which is specific to our South African standards. So you need to go create these catalogs by hand. As well as for the design and analysis, it's typically carried out in other software packages, namely EPANET. So that's one of the downfalls when the previous civil engineering. There is pressure networks of capabilities inside of Civil 3D, but the analysis part is completely removed. So just to give you guys an illustration, this is basically a typical type of pipe catalog that's actually inside of the normal Civil 3D. As well as I mentioned, you need to go to EPANET to actually do your analysis. So that's just a quick overview of those ones. And now we can move on to the red team. So the red team consists of Civil 3D and Devotech iDAS. And let's have a look how this is actually working. So first things first, the gravity pipe networks. So the stormwater overview, it's basically, yet again, we need to manually model the pipe networks using Civil 3D, or we can actually use the automated pipe networks using Devotech iDAS. As well as the next step is Devotech iDAS has established all of the catalogs for pipes and structures, which is already in compliance with our South African manufacturing standards for stormwater and sewer pipes and structures. So literally, you don't need to do all of this catalog buildup. It's already there at your convenience. Then for the network design and analysis, it can be carried out with inside Civil 3D without exporting anything. And I mean anything. The pipe size can be modified within Devotech iDAS wizard, and the design data is replicated in the profile bands, for example, the velocity and discharge. And that's what I want. I want to do less amount of effort, so my accuracy is much more up onto point, because these things are very critical. When the model has been updated to Civil 3D, you can simply reanalyze the system and just verify if it follows the design specification. So if I do small little adjustments on my layout, it actually just goes back to the analysis. I can just check and Bob's your uncle, there you go. There are different import and export options available to share your designs with other software packages using Devotech iDAS. So if you are collaborating with other engineers, you have the capabilities to export them. So just a quick demonstration. Now, I am not going to dictate exactly how I created the stormwater networks. I'm going to put that emphasis more on the bulk water, because there's a lot of guys that actually want to see that. So for now, I'm going to just start off explaining for a normal stormwater management inside of Civil 3D, and I'm going to use my Devotech iDAS commands. Now, Devotech iDAS has nice pipe designs capabilities to actually create them as well as to do analysis. If I go and say, for example, create, this wizard actually creates the pipe networks, and that's what I've used to create these elements inside of Civil 3D. So if I zoom into it, you can see there are very nicely defined structures, and that's an actual 20s KI. So where does this come from? Now, basically where this actually comes from is inside of my settings tab, we've got our parts list, and these parts lists we actually contains all of our elements. Now, these part lists are included into our Devotech iDAS templates. So if you purchase the software or you come for our training here at Modern AEC, we provide you with these templates. So just to showcase to you, there are the actual South African standard structures. There's a curve inlet for JR as well as for Twani. So you can see for Twani, there's a few examples for the actual catchment lengths as well. We have also got Insulaneni, as well as the curve inlets and outlets for dummies and all those elements. So basically, we've done all of the hard work for you, so you actually have access to all of these structures. Now, the one thing you need to specify is just to make sure the outfalls are already pre-designed, as well as I've already done the long section just to model it in profile view. So all that's actually still requires is you can use the grade pipes and adjust inverts to assist you with this for the regrading of these pipes. There's also nice commands for regrading pipes. The old-fashioned way is you literally need to go select these elements and do it by the grips, which is very tedious. That's why Devotech iDAS has a very nice tool. So after you specify those elements, you need to go and define the catchment areas. So you need to literally create the catchment areas, and that will actually be brought into my manager. Now, how does the analysis basically work? If I go to my stormwater manager, and inside of the stormwater manager, it actually works as follows. So as soon as I do that, it picks up the entire network. And as you can see, yet again, this is all in Civil 3D. If I go to my structures and inlets, basically it indicates all of my inlets. And if I add junctions, outfalls, it picks up the outfalls, as well as you have the ability to add pump storage units and so on and so forth. If I go to conduits, it's basically my pipes. So it picks up all of my pipes, as well as the pipe sizes, and I need to go specify the thickness coefficient for these elements. So let's just make this bigger. As well as it'll bring in already all of my catchments. So it picks up all of the catchments itself. So how does this entire catchment be defined? So you select the catchment first, and then you need to go to the catchment side properties to define its details. For example, if you go to the catchment side properties, you can specify what type of method you're using, hydrology method type, if it's rational or F or swim, as well as what's the rational time of concentration method you're using. Is it Kirby or Kirbysh? So then you can specify if it's a rational minimum allowed time of concentration, as well as your ascending limb multiplier, descending limb multiplier, and so on and so forth. As well as the IDN curve, you can go and specify which is already in there, but you can generate your own one if you want to. So you have that capability, as well as defining which rational IDF curve return period you want to analyze this catchment for. Then the second element which you start to need to go define is the actual catchment properties to define the runoff coefficients for them. So you still have the ability to switch the inlet nodes as well from here, as well as the roughness coefficient. You can specify the external roughness coefficient if you've got an internal roughness coefficient or a Kirby roughness coefficient, depends on whatever you're using. But you also have a composite runoff coefficient, which I also did similarly in SSA. So let's say, for example, you want to specify 80% is grassway and 20% is basically paving or road. So you can go and define those elements, and it will also create a weighted coefficient for you. So if this is a bit tedious, you can also go and specify more details a bit later on, as well as it brings in the idea of curves to tell you exactly what that intensity is. So you can go define all of those elements. And then, like I said, you could also then specify the inlets, because you can either select this manually, or you can say search for automatically. So if it is inside there, it will actually pick it up. As well as the average slopes, you need to go define the longest path. Now, what you can do is you can actually draw these polylines beforehand, automate selected flow path, or you can say draw flow path polyline. Now, as soon as you do this, it actually picks up the average slope along that entire area, and it does that calculations for you. It specifies the length, the time of concentration, and then it works out your intensity. The roughness coefficients can also be override. So just to show you, I've actually just done that one, but you can do overrides for roughness coefficients. So this is actually defined inside of the catchment properties, and you need to do this for the entire catchment, but you can do a quick select and do a quick override, for example. So if you say fill selected elements, let me just say override and do that again, and say fill values in selected parcels. It specifies for all of the roughness coefficients. I can simply do that. So as you can see, it adds all of those elements and it works out the discharge over that entire catchment areas, which is actually going to flow into your inlets at the end of the day. So you have that capabilities to do that. Now the next step is the design criteria. How are you going to design your piping system? Are you using rational or EPA swim, as well as what the routing modules you're using, dynamic wave, kinematic wave, or steady flow? You can actually go define them, as well as how long you want to run this analysis. You also have got dynamic wave settings if you specify the dynamic wave system, as well as pipe design rules. So you can preliminary set up design rules so that your network is being designed accordingly to the minimum pipe cover, the slopes, the depths, and so on and so forth, as well as the potential flow depth. So some industries actually say 75%, some of them say 80%, depends on which institute you are designing for. So you can set up all of those settings still inside of Civil 3D and Devotech iDAS. I did not import or export anything yet. Now, after I've actually done all of the hard work, I can run the analysis. So as soon as I run the analysis, you can see I get a little indication. There's a little bit of warning. So let me just have a look. So inside, I can have a look and to see my pipe sizing. So it tells me the minimum diameter for these pipes or this one, as well as it will tell me the design flow and this velocity and discharge. So it gives you warnings if you go specify exactly those elements. You can always go check for the maximum flow Q and maximum flow depth, is that your pipes is not being flooded. So normally it's a percentage wise, you can actually go and have a look to see if your entire areas are being flooded or not. So these are the criteria you can actually go and have a look at. Now, what about if I want to swap a pipe? If I select a pipe, I can actually do it inside individually if I want to select one. But the beauty about this, I need to reanalyze it and I can go and check my velocities and my discharge just to make sure it's still up to standard. But if I want to swap multiple, there's this nice little button that says apply minimal pipe sizes to all of them. So I select all of the pipes I want and I swap them to the one I'm looking for. So there are different types of sizes. So you can select whatever type you want, as well as you can go define which ones are still available in South Africa or not, because some of them are discontinued. But you have that option to go crazy and select any type. Now, as soon as I do that, it actually swaps all of the parts already. If I rerun the analysis, they're actually updated. Now, if you do update these data, it actually will bring it into your Civil 3D automatically. You also have a nice little view that actually indicates to you your analysis and velocities, as you can see. So it looks very similar to EPANet, but basically it tells you all of your velocities, your head, your total inflow, you can go define. If I go to reports, you actually have more functionality to see your results. So you can go define if you want to see total inflow, lateral inflow, velocities, and such. And you can also go select elements. For example, if you want to see the outfalls or certain pipes. If you want to see the flow, velocity in pipes, you can select one pipe or multiple pipes and compare how these velocities are actually running inside of your pipes. So this is also a very nice tool. If I go to more details, you can actually go define detail formats, which you can actually save to an Excel file, as well as the summary of all of your pipe system, which is the minimum and the maximum and the total. You also have got the EPA swim type of report. You can actually go and have a look and inspect, as well as the normal report actually is the one that also dictates all of those elements to you. And this report you can actually export to Microsoft software packages, for example, Excel or documentation. As well as quantities, you can actually go define your quantities. You can export the quantities and you can actually go and save those for future reference. As well as the volumes for the bedding, it actually does the bedding class, the total excavation, the bedding cradle, and a compacted selected full blanket, as well as the refill, and gives you nice little summaries of the pipe lengths, as well as the structure depth summary. So you have all of those capabilities inside of Civil 3D and Devotech iDAS. As well as you can import and export these data, especially if you want to share it with some other clients as well. You also have got advanced rename settings. You can add curve patterns and rain gauges, as well as this nice little function to draw profile views in the entire network. I used for this one specifically because it saves you a lot of time. Rather than doing it the manual way, we literally need to create one by one. After I set all of it, I can say update the part data inside of my model and say okay. And now if I'm back in Civil 3D, I can simply go and navigate to the elements. So let's see if those pipes are actually been updated. I think this is pipe 10. We're looking specifically for pipe 1 because I actually swapped that pipe. So the right way to finding pipes actually is if I go to my properties tab on the network stormwater pipes, then I can go and redefine them. There's the one. It says actually 600 millimeters, but let's say right click and select. There's my pipe number 1. So if I go to its properties, it also says it already automatically swaps that pipe for you. So you don't need to do that anymore. As well as in my long section, my energy grade line and my hydrology grade line actually also has been updated. So it's actually presented. As well as in my log sections, you can see it adds the 600 millimeters details. And then the most important part, the hydraulics. So it tells you the hydraulics for that specific design and velocities that is required. So as well as if you want to import and export these elements, you can simply export it either to Civil Designer, CSV files, INP, TechnoCAD, Water, import to Geno, or TechnoCAD Storm and Sewer Water. So you have got all of that capabilities already inside of Civil 3D and Devotech iDAS. So then for the pressure pipe networks, the bulk water overview. So I did get a lot of requests on this one, so I'm going to put more emphasis on this. So how we actually design a bulk water is the following. Yet again, you can either manually create the pipes and the structures inside of the network in Civil 3D, or you can use the automated pipe networks using Devotech iDAS, which I am going to show. So the Devotech iDAS has established yet again all of the catalogs for the pipes and structures in compliance to South African status, especially for water reticulation, as well as bulk water pipes. And then the network design and analysis can be carried out within Civil 3D without exporting everything. Thank you. That's so awesome. Then we can actually go take it a step further. We can actually do a system curve calculation, which I can then define if my entire network needs a pump. And then I can actually add a pump and boost the water pressure between reservoir structures. Now, it also includes, I can add air valves, scour valves, pressure reducing valves, non-return valves, fire hydrants, house connections, and many more structures that may be added to my water network. We'll have a look into that shortly. As well as the pressure analysis can be done inside of the Water Manager wizard, and reports can be extracted, views, and quantities can be saved to any Microsoft formats. The design data will be expressed in the profile bands. Basically, you will see there's hydraulics, fittings, classification, slopes, and pipe inverse levels. Then finally, the piece of the resistance. There are various import and export options available to share the design of the software packages using Devotech iDAS, which includes basically EPANET, CSV, Civil Designer, TechnoCAD, and Geno. So you can actually go and export all of that artwork you've done inside of Civil 3D and Devotech iDAS. So a more practical approach. So I am going to go a bit more in depth with this because there's a lot of demand for it. So just to start off, I've actually got an existing surface and I've indicated where my reservoir is going to start and where I want a tank. So I want to design a bulk water system for reservoir to tank. You could actually do it for reservoir to reservoir. You could do it reservoir to borehole to reservoir, and so on and so forth. So I'm just going to make it clarity a little bit better, and I'm going to switch off that surface. So the main steps that we normally have to do before we start is you need to have the right templates. So let me just elaborate a little bit on the templates again. If I go to my settings under water and I go to pipes, and inside of pipes, basically we have yet again all of our South African water pipe system standards in here. So as you can see, there are multiple pipes already created to our South African standard. So it saves you a lot of time and hassles. The same for the structures. There are the access manuals, air valves, panes, boreholes, existing water connections if you want to, double house connection, end cap, expansion, fire hoses, fire hydrants, as well as horizontal and vertical panes. We've got pumps, we've got reducers, we've got reservoirs, we've got saddles, we've got single house connections, we've got tanks. We basically got vertical panes and even water handling illuminators. Very nice. So the actual steps is to actually go draw out this as a polyline, because that's how we can automate our designs to change them into structures and pipes. So I'm just going to set up a nice thick little line. And what you need to do is simply manually go and draw out how you want your pipe network. Now, if somebody provides you with a polyline, you could also bring that in and generate your pipe networks from there. So you literally sketch out how you want your bulk water pipelines to be actually added, as you can see. So let me just make this bend a little bit easier, and the tank is going to be somewhere over here. So as soon as I do that, it actually finished drawing out the entire polyline. So now I need to go to my Devotech iDAS command where the actual water is, and I can go to the bulk water wizard. There's a specific wizard. So you give it the name and you specify what parts list as well as what type of pipe you want and what type of structures and the final surface you need. Then I can simply say next, and then you can go define the alignment styles as well as your long sections and what type of profile views you want. Now they can also go specify the minimum pipe cover as well as divide the pipes at intervals. So you will pick up and divide them accordingly, as well as to specify the pipe profile we need. So as soon as I do that, it's going to ask me to select the polyline. So I select the polyline, and then I select the position where to place this long section. So in a nutshell, he does all of the hard work for you. And Bob's your uncle. There you go. You've got already your long section. So as you can see, it swaps out that polyline to actual structures and pipes. And if I zoom to my profile view, you can see it adds all of these pipe networks into them. Now, you're not limited to what just in here. You can actually go and modify them even better. So just for clarity purposes, let me just select my profile view and let's change some of these settings. I just want to switch off the major, horizontal, vertical, and switch on the geometry points. There we go. So it looks a little bit cleaner, so everybody can see much easier. So what you still can do is, inside of this entire profile view, you can still go add structures, you can swap structures, and so on and so forth. Like say, for example, some of them are very steep or very deep. So what I can do is I can actually go and say insert a structure. Let's say, for example, I want to add another structure. If I select insert structure, I can go and specify for what network it is and what type of structure I want to add. So you can add, let's say, for example, any type. Let's go and let's say, for example, we want to add a pin. It also allows you to specify the depth below NGL in meters for the pipe. So it's going to ask you to select the profile view first. So you select the profile view, then you select the pipe and where you want to insert that structure, and boom, it adds one already at a 1 meter depth from NGL. So you can actually go with the same command, do it previously on other pipes. As you can see, we can add multiple. So this is very nice. You can do this for the entire network all the way till the end. So you can actually go define those levels. Now, some other elements you can also go and have a look at is, for example, if you want to move a structure. Now, sometimes moving a structure in a profile view is very tedious in Civil 3D, but with Devotech iDAS, we've got this nice little move structure command that says select the structure, and then we'll move it in the profile view only. So it's still on the same geometry of the alignment, but you can actually go and move it out. So as you can see. So this is a very nice specific technique because sometimes moving these elements are a bit tricky just using normal Civil 3D on its own. So yet again, you just select the structure, and then specify the new position, and then you will actually go and update where you want to place that. So the other element that we need to start discussing is, okay, we've started now with junctions. What about the rest of the structures? I want maybe, for example, more elements inside of my system. So you can also use the grade pipes, for example, command. I also want to just showcase that. If I select the one structure in between another structure, let's say this lower point, we have this grade command that actually can grade multiple pipes simultaneously. So it's going to ask you, do you want to apply a drop as well as specify the pipe matching inverts or ground or centered? You can actually do that. As well as they need to provide a value drop between the structures. Now, I don't want that. But if I want a specific slope, let's say 1 in 30, you can see it regrades that entire pipe network at once. So the one thing you need to do just to make sure is on the other side, I'm just going to do this is much easier just to move out that point to make it connect. But basically, you can still use either combination of the grade pipes to move these elements or regrade pipes systems inside of Devotech iDAS. So it saves you a lot of time when doing these designs in profile view. Then if I want to swap out any structures, I can go into say swap structure. This needs to be a reservoir. So I go to the tools and select the structure I want, and I'm looking for the reservoir. So as soon as I select the reservoir, I can actually select it and it will swap it out to the actual reservoir itself. So there we go. Here's actually now an existing reservoir, and I can still do this now for the air valves, the scour valves, and for my tank. So basically, if I zoom in to the end of my system, I need to go swap this thing out to a tank, because we're going to illustrate the tank itself, where I can go define and select the tank. So let's just go downwards a little bit. I'm looking for tank. There we go. Tank. And I can select this structure, and there's the tank. So as soon as I do that, it adds the tank to it. Now, yet again, like I mentioned, you can still go swap out these things for the air valves, as well as you can even add elements. So let's say, for example, you want to swap a structure in the profile view. You can also do that. So for example, if I want to say, for example, I'm looking for an air valve, the air valve, I can go select, and then literally you can select multiple structures. That's the beauty about this Devotech iDAS command. You're not limited to just one. Normal Civil 3D, you literally had to go select one by one and then swap them out, and that took forever. Now with this Devotech iDAS tool, you swap out multiple structures at the same time in long section and in plan view. Then for the scour valves, let's just add a few scour valves so you guys can just get a feel of what type of elements we've got inside of our templates. If I go to the scour valves, I can go and specify exactly where my low points are. I'm going to actually put that one as a pump later on. So let me just select one of these ones and select another low point somewhere over here. Just for illustration purposes, I'm not going to do too much depth design for this. But basically, if you just simply select all of those elements and press enter, you actually go and add them to your system. So you can swap them out with ease. Especially, you can still go add more structures if you want different types to add them inside of your long section or in plan view. So sometimes you just need to run an auto map to make sure all of the data is corresponding in my long section again. And there's also some very nice tools that you can actually do. If I go to my profile, there's something called profile from pipes. And let's say, for example, I select the bulk water. It will actually create profiles already for specific elements. So for example, if you want a profile for your outside top, ground center, invert, outside bottom, or range, you actually have the capability to do that. So as soon as I do that, I select OK, because I want to compare if my NGL and my top of my pipe is actually in a specific 1 meter increment. So if I know if I've got deep excavation or shallow excavation, that needs to be taken into consideration. So for example, if I go switch on my line, what you see, it actually does add that profile. And now the beauty about this is inside of Devotech iDAS, I can simply go back to my profiles tools, and there's a nice little function that says compare profiles. Now what it does is ask me for the intervals. You can specify how accurate you want these things at per interval, and it's asking you to select the profile view, and I can select the profile view. As soon as I do that, it's going to ask me the following questions. It's going to ask me for the NGL surface as well as that profile view to actually start generating. So you can see you can specify profile 1 and profile 2, and then you can specify your minimum difference and your maximum difference. So it will indicate with you with a nice reddish color if your elements are in certain specs. So you can compare if your bulk network is deep excavated needed or shallow, and you can use this as a check. So it saves you a lot of time when recreating these elements. Then you can already, before running the analysis, have this requirement checked out. You can also export these data to CSV files for clarity purposes and reference for later use. So after you've added all of the structures, you can actually go swap elements out. You can still add pumps, air valves, and all of those things. So I'm going to just jump a step because I'm just cleaning this up. You can add labels to these things, and I just made it much more prettier. So I've added now annotations as well as I add data for the pipes, but I want to move on to the next step for the actual analysis part. So what I want to do is I want to actually add an actual pump to the system, but first I need to know what's my system curve, because currently I don't know if this water is actually going to go reach to the tank at the end of the day. So I need to swap out the structure just to as a junk or at any junction type, it can actually be used. Then what I want to do is I need to go set up some settings inside of my Devotech iDAS that will actually give me the system curve. So as you can see, this is where the location of the pump is. Actually, it's just a normal structure. It's not the pump itself, but that's exactly what I'm looking for. I just need to check for this specific pipe name, what type of pipe this is because this is very critical when it comes to our designs. So what I can do is, after you've now cleaned up all of these models, I just need to make 100% sure about that pipe naming. So if I look for my structure quickly, there it is. It's actually P6. And I'm going to rename it because this is a very critical element in my analysis. So I'm going to give it a proper naming. I'm going to call this pump out. And there we go. So this is very critical because I need to go specify these elements inside of my manager. So after that, I can simply go to my Devotech iDAS command, and inside of my water, I can go to, you could either, like I mentioned, we use the bulk water wizard or the water manager. If I select the water manager, it actually will open up the analysis part. Now, how does it look like inside of Devotech iDAS? Yet again, it looks very similar to stormwater. It also has structures and has its pipes. So you can see all of the pipes are there, and I need to go specify the roughness coefficient. Depends on which analysis type you're using. We're going to use Darcy Vespa. Then we can specify the roughness coefficient for, according to that standard, to be 0.015 roughness coefficient for my pipes. So that's the first step you need to do. Then for the structures, you can see it picks up the reservoir. And inside of my reservoir, I can specify my pressure head at that reservoir. Let's say, for example, 5. As well as if I've got a tank, you can actually do a tank sizing already. So you can specify your minimum level, your maximum level, the diameter of your actual pipe that's going into the tank. And we normally put this to 1000 because I don't want my tank to actually run out at the end. So what you can actually simply do is, if you go to the design data, you need to specify whatever head loss formula you're doing, as well as the end analysis, how long you want to run the analysis. So I don't know if the actual amount of water is going to reach my tank. So let's quickly do that. If I run a quick analysis, that's basically how easy it is. You specify the pressure heads, and then we go to the pipe conduits. And there I can see I've got a flow, which is a negative value. I've also got a velocity, which is an exclamation mark. So what basically does that mean? It basically means there's no water going to my tank. It's not sufficient enough to go into my tank anymore. So what can I do? This is in a case where I need to start thinking rationally. Maybe I do need a pump. Now, how do you define a pump? Now, the way to get the system curve, so it gives you an idea how much you're going to need. So what I need to go specify is just the demand. This is an estimate. You can specify any type of demand you think that's required, and then we can actually go and add a certain pattern for it, because a pump system curves is normally in different segments. And then something I need to make sure is inside of the pipes, the pipe out, which we just marked, I need to close it, because the reason why I'm going to close this is because it's going to allow me to actually run an analysis, and it will tell me exactly what my system curve is. And that's what I need to compare to an actual pump, which I normally get from my manufacturers and so on. So what I need to do is I need to just close the pipe before the pump, or in this case, the junction, which we said is a pump. And then I need to go to specify a pattern. Now, the reason why we specify patterns, so we can get more accurate results. Let's say, for example, I want to know half of this demand. Let's say, for example, 0.5. And then I want an actual scenario. I want a pump that actually needs to give me values at 60 demand and then double it. So I have a nice little system curve. You can still add more elements to be more accurate. But to get the more accurate system curve, we need to set up this pattern and assign the pattern to this element. So as soon as I do that, I can specify the inflow pipe. I made sure the pipe is actually selected, and I need to just rerun the analysis. Now, the analysis I'm going to run as a two-step analysis and run the analysis itself. As soon as I do that and I go to my report, it indicates to me for the first run at pressures 30 liters per second, I've got these values. And then for the second run for 60, I've got this 98.91 pressure head. Then for the 120, I've got a 135.01 pressure head. So that's going to give me my actual system curves. But you can actually go to the graphs. And inside of the graphs, you can actually go select the pump junction box. And there is my system curve. So this gives me an indication of how my actual pump needs to be. So I can actually follow these elements directly, and then I can do a proper design for the pump. So there are several ways of doing this now. How do you go in about adding the pump? Now, very simple. The first thing we need to go define is I need to take out all of those settings which I previously done. For example, the structures, I need to go and maybe take out the pressure. You can see the pressure has been added as well to this, but I need to go and take out all of that previous steps I've done. So for example, if I need to go and define the pump itself, I can simply go and take out the demand. So I set it to 0. Just cleaning this up pattern again. I need to go to that pipe, which I closed. I need to open it. Otherwise, the water will not flow for the next step. So if I say, okay, for now, I need to physically go swap out that structure as an actual pump, which actually has power. So I switch it out to an actual pump, and it actually updates accordingly. So now that's an actual pump structure. If I go back to my water manager, I'll just quickly open that up. And it will actually allow me now, if I go to the structures itself. So inside of my water manager, I can go to structures, and under my structures, let's make this bigger again. If I go to pumps, there's the actual pump. So inside of this pump, you need to specify the outgoing pipe as well as the curve. Now the curve you normally get from the manufacturers, so you know roughly what type of pump you're using. So what you can do is you can create your curves inside of Devotech iDAS. To create a new one, you simply go and create them. So let me just delete the existing one, so just to show you. And let's go and create a new one. Let's call this, for example, pump, curve, and okay. Okay, just gonna have spaces, there we go. So what you can simply do is you specify this is a water pump curve. So it asks you for the flow and the head meters and decreasing. So you specify how many rows you want. So I'm going to just add 3. And let's say, for example, I get the manufacturing catalog pipe system on my hand, and it says it has a system curve for one of them for 40, 80 liters per second inflow, and the last one was 100. And I can go and specify the actual head. It provides me this pump at these certain increments as I go along. So you define actually the entire pump system curve inside of Devotech iDAS to create a new pump curve. Now, after I've added that pump curve, I can simply say okay, and it's going to ask me to select the pump curve. You can either select pump curve or power. If you have got specific to power, it also works. Then you don't need a curve anymore. Then finally, for the design criteria, we'll just make sure we run this analysis yet again for a 3-step analysis system. So it runs for those 3 cycles because I specified it in my curve. And if I go to my report, I can see exactly reservoir is emptying, tank 1 is filling up to 1 meter because I set that to be 1. And then I can go and have a look at the pressures inside of my report. So there's for the first step, the second one, and for the third, if I go down, it actually has that pressures. Then for the structures itself, in the nodes, I can actually see the pressures. So you can see it actually has the pressures already, as well as the pipes. The flow is now positive value. It basically means there's a sufficient amount of flow, and the velocity meters per second is not having warning. I can also go view this in the view tab. If I want to see pressures or head or velocity, you can actually go define all of these elements in the nodes to switch on whatever you want. Let's say just the nodes. And there I can see the pressure I've got and where my pump actually is and where it pushes out to have sufficient amount of pressure to my tank. So you still have got all of those capabilities to view these elements, as well as I want to update these elements. And also, yet again, you've got quantities, so you can specify the quantities as well. Now, after all of this has been done, we've got the beauty about Devotech iDAS. It basically does the hydrology and energy grade line again for you, as well as it defines your hydraulic data, as well as if you've got fittings, it tells you if you've got a straight fitting, 11.25 fitting, or whatever type of fittings you have. So actually modeling these things up, analyzing it, it's all much easier inside of Civil 3D and Devotech iDAS. Okay. So it saves you a lot of time because, like I mentioned, all has still been done inside of Civil 3D. So, ladies and gentlemen, to the end, the final wall report and statistics of this entire scenario. So I'm going to do something that I've never done before. And this time, I'm going to let the audience have the opportunity to vote. for which one do you think is the best and which one you prefer. So we will quickly run a poll, which is actually you guys deciding which one you would prefer to go to war with. And when I'm talking about war, I'm talking about your project, civil projects. So just give you a few seconds for the guys to give an answer. Okay. We'll just give a few more seconds for the guys and let's see the results. And ladies and gentlemen, it's a drum roll. 94% says Civil 3D and Devotech iDAS has won the war. Thank you so much, ladies and gentlemen. This is a new type of approach for me and I'm glad that we did it. I get really good feedback on this. So just the final Civil War reports. In the end, basically we're all on the same team. Civil 3D and Devotech iDAS versus our common enemy, which is basically civilization and environmental impacts. So ladies and gentlemen, my final words for this series of the Civil Wars is that every engineer out there is a superhero. We have dedicated our time, our passion for finding better solutions to everyday demanding tasks, only to give our children and our country a better future. So pat yourself on the back because you are a champion, ladies and gentlemen. So more webinars. So if the guys are interested, say for example, you missed the first few webinars, you can actually go visit our Autodesk website or view our YouTube channel to see upcoming or previous replay videos accordingly. I would highly suggest if you guys missed out the first Civil War part reenactment, you can actually go and have a look at that specific webinar, as well as we've got Introduction to BIM 360 Design for Civil 3D, as well as the City Series Civil webinar. I would strongly recommend for the guys that's using Civil 3D integration with Revit, how to bring in your topographic surfaces as well as your shared coordinate points. So feel free to have a look at those as well. They will also be posted in the link as well. Then, ladies and gentlemen, we get to the fun part, the question and answers. So frequently asked questions. Can I design sewer networks in Devotech iDAS? I did not cover it, but yes, there's an entire sewer specific wizard that actually does that analysis as well. Is Devotech iDAS part of the AC collection? No, it's not. It's actually a separate package on its own with its own licenses. So where do you get more information about licenses, pricing, training, and live demonstration from Devotech iDAS and Autodesk Civil 3D? That was fast. So you can simply contact Salome, our infrastructure account manager, who would be happy to assist for any of those additional elements you require. So ladies and gentlemen, I'll have the floor open to you guys for questions and answers. So let me just quickly open up the Q&A. Okay, let me have a look. So there's an option, can you use the program to design open gullies? Yes, you can actually. We can actually go a step further, really. We can actually design a stormwater network. Let's say, for example, from a certain drainage up to a certain drainage, I've got a stormwater, and then I've even got a channel, an open channel. And then you just go back into the stormwater network. You can actually do that as well. We can actually analyze that in our Devotech iDAS, as well as we can actually go even more further. We can actually do a proper detention pond design. Then there's another one from George, sewer rising main design in iDAS. So yes, George, we can actually do sewer rising designs inside of Devotech iDAS. Like I mentioned, I did not touch upon sewer, but yes, we can do sewer designs inside of Devotech iDAS and Civil 3D. Do you provide detailed training on the use of iDAS? Yes, we specify specifically for those. So we've got Devotech iDAS training. We've got the essentials, as normal is Civil Essentials plus an additional elements we show for iDAS. Plus we've got advanced courses. The advanced courses basically is break down into two components. We've got advanced piping courses. Basically, it covers all of your piping designs. For example, stormwater, bulk water, sewer water, water reticulation, we cover. We do tank sizing. We do culvert designs as well. I did not mention that. We do culvert design, but those are in our advanced courses. The second one is actually dual carriageway road design, but it's the advanced course. So we showcase how to do roundabout designs. We showcase how to do cul-de-sac designs. We show how to do dual carriageway design. We show how to create advanced assemblies for your roads. If you've got dual carriageway roads or highways, we actually show you how to do that as well. So all of those are covered in the advanced courses. Then I've got one from Bendile. If my pump is inside a sump, how do I set up the level and make sure that I am using the correct head? So Mandili, what you simply can do is in your structure, we actually have modified that functionality that you can actually go and move it below into the sump bed, and then you can actually just specify that head inside. But that's normally covered in our training as well. So we have improved that. That was a previous issue. So you just really need to take it into the sump, and then you specify the correct head to take that into consideration. Can either show sewer house connections in the long section from, I'm sorry for mispronouncing your name, Kuvasan. Yes, we can. We actually, there's a specific, let me just go to my Civil 3D. I can actually show you. So in my Civil 3D, this is now the actual element. You've got a nice little function that says project house connection line. It actually shoots the actual project house connection lines directly to your long section if you have got house connection. So does iDAS include Cape Town standards? So it depends on what type of Cape Town standards you're talking about. Is it specifically for certain catalogs? So just so you guys know, if there is a new manufacturer or new catalogs that's been issued, and say for instance in South Africa, and you've got licenses from us, from Moderna ASC, we actually provide the additional add-ins for you. That's why we have that service. So if there's a new manufacturer coming in, we update the catalogs and do this. So you send us the catalog and we add them for you and send you the updated templates. And then we actually take that template and reuse them again over and over and over again for the future. Does the catalog have steel pipes, and can I use different pipes in the same model, example steel and UPVC? Yet again from being dealer, yes you can. You can actually swap the different pipes or systems in between, if it's the steel pipes and different pipes are the same as UPVC. Like I said, this catalog is very big. We've got a lot of parts lists in this element. So for example, let me just go to, let's say, water. Doesn't really matter. But basically, I think it was just a bit too far. We've got Dilfried UPVC. That's the UPVC ones, ultra flow ones. Mali, you've got Mali, you can actually use that one. As well as the steel ones are actually here. There's Aquaflows ones, the steel pipe walls. Like I mentioned, if this is not included into the catalog, it can be added to the catalog. As soon as you've got any license from us, we provide the services to update these catalogs accordingly to South African standards. So I just need to have a little bit clarity on the Cape Town standards, exactly what standards. So I just want to quickly run through and see if we've got all of the questions. So there is a question, can I get a standalone license or once-off license? Okay, Salome will contact you personally on that question. Okay, so just regarding the Cape Town standards, you can just send us an email, just specific what type of standard you're looking for, because you get different types. For example, the same for roads. So roads has Sunroll standards. I just need to make a little bit more clarity on that. If you can just send Salome an email, then we can contact you and be in touch regarding that question. Okay, ladies and gentlemen, we have run out of time. From my side, I want to thank you once again for joining our webinar. And we'll see you guys shortly soon. There are still upcoming ones that's still coming in short time. Oh, as well, there's something to point out before I leave. If you guys want to see specific elements, I normally do polls, but you still have the ability to actually give us an email to actually go specify what type of webinars you want to see. What are you interested? Because at the end of the day, we are still developers. We are not a final product. We're always looking at better ways to improve our packages, as well as finding awesome workflows. So you're more than welcome to actually come send us an email into what you actually want to see at the end of the day. So please send your request so we can actually schedule up a new webinar for the specific request. All right, ladies and gentlemen, from my side, once again, thank you so much. Enjoy the rest of your Friday and enjoy the weekend. Cheers for now.